It's a great honor for me to present these papers for the audience. This paper is not much detailed studies. It's just some preliminary ideas about the new direction or new potential for the different ideas for the SSP development. So up to now, there are about the two configurations, the general configurations for the development of SSPS. First is to build everything in the ground, in the Earth, and launch all the facilities to the orbit. The second one is to build everything on the lunar surface using the in situ resources utilizations. So those are the only two configurations to development for development of SSPS. So in this paper, a new concept has been suggested to using the same technology for the like the ISRU, but with a different targets. For example, the near Earth asteroid for the in situ resources utilizations. Also, the 3D printing technologies have been introduced to improve this concept. So in this paper, we'll discuss about the future, the features of asteroid, the 3D printing in orbit, and also introduce some new progress in China. So the solar power is a very huge project. It will launch a lot of mass into orbit and need a very heavy duty launching vehicles. So it will cost a lot of money for the transportation. So the ice breaking point will be the cost reduction in terms of manufacturing, transportation, and also the maintenance by at least one order of magnitude to compensate the other source of energy. So in China, in the Ssps Science Conference, some of my colleagues, including myself, suggest the possibility of using the in situ resources utilization for the development of SSPS. So the different possible means of cost reduction of SSPS, including the RSRU and also the 3D printing, and also the so-called massless proportions, such like solar cells, and also the EM drugs suggested by UK scientists. So the strategy to reduce the mission cost of SSPS should be a combination of ISRO 3D printings and also the massless proportion. The ISRO in this paper mainly means the capabilities of resource extraction and also the resource processing to provide the raw materials for the 3D printing in space. Even the solar cells, according to the recent technologies, it could be 3D printed. The second, we introduce some features of a near Earth asteroid. The AEA is any asteroid whose orbit brings into the proximity with the Earth. It has some very detailed definitions, and it can be categorized in three groups, like Apollo, Ankin, and also Emma, with the different perihelions and different apohelions. Some NEA are of lower mission velocities than the Moon due to the combinations of low velocity with respect to Earth and also the very weak gravities. Normally, if we go to the asteroid starting from the geo, its direct V should be less than 2 kilometers per second. But if we go to the lunar surface from the geo as a start point, it will be around 4 kilometers per second. So it's about 2 times compared with the asteroid missions in terms of delta V. So that is one of the reasons we choose NEA for the ISRO. This picture gives clearly figures about from the geo to the surface of the moon and other points. Since NEA has a very weak and very diffuse, so we can use a very small thrust, like the thrust provided by the solar cell, and also the thrust provided by the electrical propulsions. But if we launch from the lunar surface, you have to use a very large propulsion means. So this is a second reason to choose NEA for ISRO. And also, the NEA has very rich resources according to the categories of different NEAs. Like the S group, they're very useful materials for the silicon, for the solar cell productions. So this is the third reason to choose NEA for ISRO. And also, there are about 1 billion NEA around the near the Earth. So it provides very big growth, big potentials for us for optimal selections of different NEAs. Also, recently, the commercial effort has been engaged for the Asteroid mining. Many companies have already been set up. So it has a very good basics for the commercial for Asteroid mining. So in conclusions, there are several reasons to choose NEA as a target instead of the moon for the ISRO. That is the low delta V, the possible using the propellant, less propulsions, rich resources, and also rich opportunities and commercial efforts. The third is 3D printing. 3D printing is, I think everyone has already will know about this. The 3D printing technology is not just using on Earth, but also it can be used in the space. Those other companies and also organizations engaged in the 3D printing in space, like NASA, ESA, and also China Academy of Space, also doing the research on the 3D printing in space. There's some advantage of 3D printing in space. Due to the time limit, I wanted to see to introduce in details. There are also some research on the 3D printing of solar cells on the ground. The highest efficiency has already reached about 19% of solar cell, which has a very high potential for the space application. Those are some samples of 3D printed solar cells. For example, in Korea, in Espanol, and also in other countries. So the suggestion of 3 steps of Ssps program. First, the air-ground experiment using the airship. Second is a milliwatt class space-to-ground WPT experiment. The third one is using the ISRO technology and also 3D printings for the GWAT class SSPS. Those are some the roadmap for the Chinese space development in the next 50 years. Those are the design and simulation progress in China. And also some key technologies like the solar panels and the very long distance unfolded truss, and also the environment studies.
Many.
Will you come back?
Your time is fine.
You can recheck.
Can we go back? Yeah.
Those are the WPT studies doing in Xi'an Institute of China Chemical Technology and also Sichuan universities. This is the result of the laser transmission experiment doing by Beijing University of Technology and also the Shandong Institute of Cost. So, in conclusion, to reduce the cost of SSPS is a very important issue. And the strategy to reduce the mission cost can be a combination of near-Earth asteroid, ISRO, and on-orbit 3D printing, and also the massless propulsions. The key space segment of SSPS program could include GEO-SSPS facilities with the 3D printing facilities, and several orbit transfer spacecraft using the propellant-less propulsions, and several mining machines for the needs ISRO to provide raw materials for 3D printings. Okay, thank you for your attention.